All right. So I just want to go through the update that I made right now. You should have received an email from me that said that that I updated the explanations to the periodic table. That was page 6 from the reference sheet. So from your reference sheets that you guys currently have, you're ignoring you're ignoring this page right here, page 6, and instead you're gonna use this page right here. Okay, again, so from the reference sheets that I sent, you're ignoring page 6 right here, and you're gonna use this page that I sent. I sent it through email, and then it's also on here. Okay, all right, so let's get started on the review. Okay, so first things first, we already finished electron configuration. We're going to go into um, a periodic table trends. So that's chapter 11, part 2. Okay, so everybody should have this out. Chapter 11, part 2. I think it's page number 11. So it asks, which one has a larger radius, C or BE? So what reference sheet are you using for that? You're going to use this sheet that I have. It's the second to last sheet that tells you what periodic table trends which go which way. So first of all, C you have right here, and then BE you have right there. And we're looking at atomic radius, and it says atomic radii decreases. So as I go across, the radius gets smaller. Okay, again, as we go across, the radius gets smaller. So which one is bigger? Is C bigger or BE bigger? Well, we know BE is bigger because that's closest to the left. Okay. BE is the bigger one because C is closest to the right. And as we go to the right, it decreases. Now, a lot of people for these explanations have been using the following. Well, as you get closer to the right, it decreases. So that's why it's smaller. You can't use those explanations. The explanations you're using, like I said, are the ones that I just shared with you. So this is as we go across the periodic table. So it says, as you go across the periodic table, atomic radius decreases because more protons and more means more and more pull. So basically, atoms farther to the left are bigger, so less protons and less electrons, we have less pull. So which explanation would I use? Well, I want to say that BE is bigger, right? If I want to say that BE is bigger, then I'm going to use the explanation at the bottom, the one that says atoms farther to the left are bigger, so there's less protons and less electrons, so there's less pull. So I would say less protons, less electrons, less pull. So this is why BE is bigger. Or you can say, remember, you can say BE because C has more protons, more electrons, more pull. So you can say either explanation. You can say BE because there's less protons, less electrons, less pull, or BE because C has more protons, more electrons, more pull. Okay? All right, I want you guys to try number 3 by yourselves. I'm going to give you like 2 minutes. Try number 3 by yourselves using the reference sheets. All right, guys, let's take a look at this. Which element has a larger radius, Na or Cs? So again, we have to look here, right? So we have Na up there. We have Cs down in the periodic table. Again, we have Na farther up the periodic table. We have Cs down more in the periodic table. It says atomic radius increases, meaning it gets bigger. And we're looking for the larger radius. So which one would be bigger, Na or Cs? Which one would be bigger, Na or Cs?
CS.
Yes, Cs would be bigger. Now let's go to the explanations. Okay, so this one is as you go down the periodic table. It says as you go down the periodic table, atomic radius increases because more electron clouds are added. So that's exactly what you can add. Just say CS because more electron clouds are added. And that's exactly as you can leave it. You can leave it as that. Okay, are there any questions on atomic radius? All right, what I want you guys to notice, we're going to do ionization energy. Ionization energy is the amount of energy needed to remove an electron. We have two trends, and then I have one trend that's a little star, and then at the bottom it says explanations can be used both across and up and down and up and down. Okay, so these explanations for both ionization energy and electron affinity, you can use the same explanation as you go across or you go down the periodic table. You don't have to change it. You can use that explanation that's underlined there. So let's take a look, for example, at number 6. Which element has higher ionization energy, P or Sb? So P is farther up, Sb is farther down. It says ionization energy decreases. Again, P is farther up, Sb is farther down. It says ionization energy decreases. So it means it gets less. So that means P has more ionization energy, okay? And then, like I said before, you can use the same explanation that is starred right here. And it doesn't matter if it's across or down. And the explanation is the following. Smaller atoms need more energy to take electrons away. So P because smaller atoms need more energy to take electrons away. Okay, like I said before, you can use that same explanation. You could also technically say P because Sb is bigger, which means atoms need less energy to take electrons away. Like you can say that one too, but I just feel like to make it easier for you guys, I've told you, you can use this same explanation no matter if you're comparing up and down or left to right. Okay, so can you guys do number 8 for me, please? Do number 8. Again, I'm going to give you 2 minutes. All right, guys, let's take a look at this one. Which element has higher ionization energy, K or SC? So let's take a look. K is up here, and then SC is actually 2 away from it. They're right next to each other. They're just separated by Ca. So it says ionization energy increases. So as we go this way, ionization energy gets bigger. So what has more ionization energy, K or SC? What do you guys think? Remember, ionization. Sorry?
SC.
So it would be SC. And again, you can use the same explanation as 6. So you just copy that. Because smaller atoms need more energy to take electrons away. Questions? All right, let's look at number 11. What element has higher electron affinity, Mg or S? So Mg is right here. Okay, Mg is right there. S is farther to the right. Again, Mg is in the left side, S is farther to the right. Electron affinity is the last trend at the top. It says electron affinity increases. So we have more. So very similar to the top. So that means S obviously has more electron affinity. Let's look at explanations. Again, explanations are not, explanations. Oh, my bad. Hold on. There we go. Explanations are these, okay? So again, as the star says, you can reuse that, you can use that explanation right here as you go across or as you go down. So we're gonna use that one that says smaller atoms are more accepting of electrons. You just say S because smaller atoms are more accepting of electrons. Smaller atoms are more accepting of electrons. That's what electron affinity is, how accepting or excited an atom gets from the addition of an electron. All right, I want you guys to try number 13, please. Try number 13. All right, let's take a look at 13. Which element has higher electron affinity, Be or Ba? Okay, so let's take a look. Be is right here. Ba is farther down. Again, Be is more up, Ba is more down. It says electron affinity decreases as you go down. Decreases. So which one has more electron affinity, Be or Ba?
BE.
Yep. So Be has more electron affinity because we decrease. And again, you can use the same explanation as number 11. You can say because smaller atoms are more accepting of electrons. Okay, you can say that same explanation. Are there any questions for periodic table trends? Okay, chapter 12, part 1, I'm not going to go over. Those are just definition questions. You can easily look those up. Those are pretty easy. What I do want to go through is chapter 12, part 2. That's the Lewis structures. This is the last thing we did. There's 3 types of Lewis structures. So there's covalent, there's ionic, and then there is polyatomic. So let's go through each one. Si, first one, SiO2. So SiO2, I want you guys to notice. First of all, Si is on the right-hand side of the stairs. O is on the right-hand side of the stairs. Both of these, as you can see, the stairs are that dark line. Both of these are on the right-hand side of the stairs, which means that this is a covalent bond, which means that they are going to share electrons. Again, if both of them are on the right-hand side of the stairs, this is a covalent bond, which means they will share electrons. So what column are they in? Well, hydrogen is the first column. Beryllium is the second column. You're skipping the whole middle, and boron is your third column. Carbon is your fourth. So because Si is below carbon, the fourth column means Si has 4 valence electrons, and that's how many dots you're drawing around it. So Si would be drawn with 4 dots like so. Then we keep going. Carbon is 4, nitrogen is 5, oxygen is 6. That means you have 6 dots around oxygen, and we have 2 oxygen. So we're going to draw 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now, everything wants to have 8. Reminder, everything always wants to have 8. Oxygen on the left has 7. 2 on the left, 2 on the right, 2 at the top, 1 at the bottom. That's 7. Okay. Si in the middle has 6. 2 on the right, 2 on the left, 1 at the top, 1 in the middle. That's 6. Oxygen on the left also has 7 because both of the oxygens should match, and they do. Okay. So now none of these have 8, so none of these are happy. What can we do to make them happy? We learned about double bonds, which means that if there is lone electrons like these, we can push these to the middle and make a double bond. Well, that would satisfy oxygen on the left. Si would have 7, but we still wouldn't be happy. But guess what? Si has another lone dot here. The other oxygen has a lone dot here, which means we can make another double bond right there. So how would this look like then? Well, this would look like the following. Oxygen would have 2, 2, 2, 2, and then 2 here. Si would have 2 dots here, space, and then it would have 2 dots here. Other oxygen would have 2 dots here, 2 dots here, and 2 dots here. So if we count everything now, the oxygen on the left has 8, Si in the middle has 8, oxygen on the right also has 8, and this is your final drawing. All right, I want you guys to try number 2 by yourselves, please. Try number 2. All right, guys, let's take a look at this one, CCl4. Okay, remember C and Si are in the same column, which means they both have 4. So carbon is going to be in the middle with 4. And reminder, the first element is always the one in the middle. Cl is in the second to last column. So remember, oxygen is 6. So that means F is 7. So everything below F is 7. So we have 4 Cls, like so. And then we have 7 dots for each. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And as you can see, everything here has 8. So there's no double bonds needed. There's no triple bonds needed, nothing like that. This is, again, these are covalent bonds. They share electrons due to the fact that both of these atoms are on the right-hand side of the periodic table. Let's look at an ionic bond. Let's look at number 3. Al, as you can see, it's on the left-hand side of the stairs. Again, Al is right below boron. It's on the left-hand side of the stairs, which means Al is a metal. So how would we draw these? Remember, Al is in the third column because carbon's in the fourth. So Al has 3 dots like so. Then we have Cl. We just did Cl. Cl's on the right-hand side of the stairs. Cl has 7, but we have 3. We don't draw these together. We actually draw these separate. So it would be Cl, Cl, Cl. And we're going to draw 7 dots. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It doesn't matter how you draw the 7 dots, as long as there's 7 dots in each Cl. So what's going to happen here? We're not going to share here. Remember, this is the one where one wants to gain and one wants to lose. Why does one want to gain and one want to lose? Because if Al loses its 3 electrons, then it has a full shell underneath. If Cl gains an electron each, then it fills its current shell. So what it would do is Al is going to pass down its electrons to Cl. So because Al lost 3 electrons, it becomes a positive 3. And because each Cl gained an electron, it becomes a minus 1. Questions? Okay, I want you guys to do one of these by yourselves. So please do number 8 by yourselves. Number 8. All right, guys, because of time purposes, let's do this one. Okay, MgO. So reminder, Mg is on the left, so it's going to be 2. It's in the second column. O is on the right of the stairs, so this is O, and O is in the 6th column. 1, 2, 3, 4, 5, 6. And reminder, again, O is going to pass down its electrons. This would become a +2. This would become a -2. Okay. Before we leave, I just want to show you number 5, please. So stay with me. I want to show you number 5. We're not going to do an example by yourselves. Sorry. Oh my gosh. Just getting a lot of pain in my pelvis. Oh. Okay. Nitrogen. Carbon is in the 4th column. That means nitrogen's in the 5th column. This is a polyatomic. 1, 2, 3, 4, 5. Okay. As you can see, sorry, I'm going to just do it down here. Okay. As you can see, for polyatomics, they are similar to covalent. They do share. Okay, they do share. Reminder, they do share. Oxygen is 6, so we're going to draw 2 oxygens like so. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Very similar. Everything wants 8. However, this has 7, this has 7, this has 7. Nitrogen only has 1 lone pair that it can double bond with. So it's going to double bond with, doesn't matter which oxygen. I just chose that one on the left. So then it's going to look something like this. Oops. I don't like how I did that. Okay. Nitrogen is going to look something like this. 2 dots there, 2 dots here, 1 dot here. And then it's going to have oxygen like this. The other oxygen is going to stay the same. Now, oxygen on the left is happy, nitrogen is happy, but the oxygen on the right is not happy. So what will we do there? We're going to add an extra electron there because we can, due to this -1 charge. This -1 charge allows us to add an extra electron. Again, only 1 though, and that's all we need anyways. And we draw that we've drew an extra electron by drawing it another color or just another shape, and then a -1 like so. Okay. Are there any questions on this? So again, I will post this video. You guys will have access to it. It will be on Google Classrooms, okay? All right, have a great day, guys.